Hello student, myself Milish Sankla, and in today's session we solve the example of Macaulay method. We already solved one example. In next example we solve another type of. Okay, so first of all read the data properly. What is given in data? Here in data given that find out slope and deflection with Macaulay's method. Okay, and right here find the slope at D and deflection at under the point C. Then using Macaulay's method, and EI is given 40,000 kilonewton meter square. Now again in first figure we can see that UDL is 5 kilonewton per meter, point load 10. In this example with given simply supported beam, moment is given. Okay, and look at this, UDL is start at A point and stop at middle one. Okay, if UDL is given like this way in Macaulay's method, we have to take a equivalent beam. Before starting this, we have to find out support reaction. Okay, and always support reaction is find out this, with respect to the reference point. So that here take with respect to reference point A, taking moment about A. Right here taking moment about A point and compare two moment, anti-clockwise moment with clockwise moment, and this support reaction RB rotate with respect to A point in anti-clockwise direction. Right RB and up to A distance is equal to 3 plus 2 plus 3 plus 2, that means 10 meter. RB into 10, and all given load and moment are rotate clockwise direction with respect to A point. Right here first our UDL load into distance is equal to 3 meter and 3 by 2. Next plus this given point load 10 kilonewton, and that is rotate clockwise direction with respect to A point, and distance is equal to 5, and moment is given clockwise, so that mention here, and moment is not multiplied with distance because moment is already multiplied with distance. Unit of moment is equal to kilonewton into meter, so there is no need to multiply moment with distance when we find out support reaction. And after simplifying we get value of RB is equal to 9.25 kilonewton in off direction. Now find out RA. And what is RA? RA is equal to total vertical load minus our reaction RB. Now what is total vertical load? First is given UDL. What is the load of UDL? 5 into distance 3 plus next given 10. Now moment is not load. Okay, so we can't take moment as a load, and RB is equal to minus 9.25, and we get RA is equal to 15.75 kilonewton in off direction. Okay, here we find out two support reactions. So mention here our RA is equal to 15.75, and consider B as a section, because according to our Macaulay's method, right hand side we consider as a section and take distance as X. This is our first step after find out support reaction. Now guys, you remember that if UDL is given like this way, stop here, so that we have to consider equivalent beam to find out slope and deflection by Macaulay's method. Okay, if our UDL is start this point C to B, there is no need to take a equivalency of, but like this type of beam subjected to this type of loading, we compulsory take a equivalency. Here we apply from this point to B point UDL. Now this UDL is extra, so we have to also apply, this is downward and this one is our upward UDL. Ultimate nullify this UDL, but we have to take a effect of this UDL in our equation. Okay, now what is the equation of moment? Right here M is equal to this support reaction is rotate clockwise direction with respect to this reference point. Right here 15.75 into X. Then next given UDL 5 rotate anti-clockwise direction with respect to reference point and distance X, 5 into X and X by 2. Next is 10 kilonewton rotate anti-clockwise direction X minus 5. Again 10 x minus 5. Point load is given, so that load into distance, and when UDL is given, load into distance and distance by 2. Again here moment is given and this moment is plus, so 20 and this distance x, and from left hand side 3 plus 2 plus 2, 7. That means x minus 7 raised to 0. If you remember, in the theoretical portion we studied that when moment is given on span, quantity x minus a raised to 0 we write down when it is multiplied with moment. Same here, this is the case of moment, and so that we have to write here 20 into x minus 7 raised to 0. Next, look at this. To balance equivalency, when we convert the beam in equivalence beam, then we apply this extra UDL, and again we have to count this effect of extra UDL in this equation of moment. So this UDL is rotate in clockwise direction with respect to this reference point xx. Okay, so right here minus, and this is plus because this UDL is rotate in clockwise direction. And what is the value of UDL? 5 x minus, and the point where UDL start, the distance is left 3 meter, x minus 3 and x minus 3 square, x minus 3 by 2. Okay, now what is the equation of differential equation? EI d square y dx square minus m. Okay, change the sign of this equation. Okay, in next we convert this sign of this equation of moment. So write again here the equation that we make of moment, convert in this differential equation. Okay, now mention here EI d square y dx square is equal to, our first term is given minus 15.75x, then second is our plus 5x square by 2, and again next term is our 5x minus 3 square by 2, and next plus 10x minus 5, and next term minus 20, then x minus 7 raised to 0. This is the equation of differential. Okay, now again first step, integrate it. Right here, integrate our first equation. Now what is the integration of d square by dx square? That is dy by dx is equal to minus 15.75 integration of x square by 2, and add constant c1 in first term, plus 5 by 2 constant x square x cube by 3, then plus 5 by 2 again, and integration of this x minus 3 cube by 3. Next 10 x minus 5 square by 2, and 20. What is the integration of this x minus 7 raised to 0? That is x minus 7 raised to 1, and this equation is equation of slope, and this is our first equation. Now according to rule of our Maclaurin's method, again integrate this term, again integrate this above equation. Now right here EI, what is the integration of dy by dx? That is y is equal to minus 15.75 by 2. Remember that there is no need to divide it. Okay, right here, write as a constant. Then x square x cube by 3 plus c1, integration of c1 is equal to c1x, plus add second constant c2, plus 5, 2 into 3, 5 by 6, and what is the integration of x cube? X raised to 4 by 4, then again 3 to just 6, 5 by 6, and x minus 3 raised to 4 by 4. Then divide 10 by 2, that is 5, x minus 5 raised to cube by 3 and minus 20 x minus 7 square by 2, and this is the equation of deflection. Okay, and this is our second equation. Now next step, remember what is the next step? That is apply the boundary condition. Okay, right here, apply boundary condition. Okay, anyone know where is the boundary condition applied? That we already consider in example number 1. Boundary condition is apply always and always is support. This is about support A, okay, and this is our support B. Now right here, at support A, x is equal to 0. Look at this in figure. Each support is the starting point, so that at starting point always x is equal to 0, and at this point y is equal to 0. Now where is the value of x and y? That is in equation number 2. Okay, now equation number 2, look at this. Y is equal to 0, that means this is 0. X is equal to, that means this term is 0. C1 into x, 0. X is equal to 0, then x minus 3, 0 minus 3 less than 0, cancel this term. 0 minus 5, cancel this term. 0 minus 7, cancel this term. That means we have to again write here our constant C2 is equal to 0. Okay, now apply the boundary condition at next and at B point, and this B point 3 plus 2 plus 2 plus 3, that means distance x is equal to 10 meter. Right here, x is equal to 10 meter and y is equal to 0. Now again, where is the value of equation number 2? Okay, now one by one we put in second equation. First Ey 0. Okay, then minus 15.75 divided by 6, and here x is equal to 10 cube plus C1 into 10, constant C2 is equal to 0, then 5 by 6 4s are 24, x is equal to 10 raised to 4, and next 5 by 3, then 10 minus 5 raised to cube, then 10, and x is equal to 10 minus 7 square. Here after simplifying this term, we get C1 is equal to 92.35. Okay, here we get constant C1 is equal to 92.35. Okay, one by one again repeating this step. First we find out support reaction, and second we find out equation of moment, then we integrate this term with 2 times, and then apply the boundary condition, and after applying the boundary condition we find out our constant C1, C2. C2 is 0 and C1 is equal to, we get the value 92.35. Now find out slope and deflection. Okay, first right here, slope. Where is the point of slope? Slope is find out at D point. Slope at D point. That means here is this point D. What is the distance? 3 plus 2 plus 2, that is 4 plus 3, 7. Right here at D point, x is equal to 7 meter. Now EI, what is first equation? dy by dx, and that is theta d. What is the equation of this slope? 15.75 by 2, and x is equal to 7, so that 7 square. Then our constant C1 is equal to 92.35, then plus 5 by 6, and x is equal to 7 cube, then minus 5 by 6, x is equal to 7, 7 minus 3 raised to cube plus 5, and 7 minus 5 square. Okay, after simplifying we get EI theta d is equal to minus 41.025. Now theta d is equal to minus 41.025 divided by EI, and value of EI again minus 41.025 and EI is equal to 40,000. After simplifying we get answer minus 0.00102 radian, and this is in negative, that is anti-clockwise. Okay, now second, find out deflection, and the point where deflection is find out, that is deflection at C. Look at this in figure. At C, what is the distance of x from reference point A? X is equal to 5 meter. Now equation number 2, EIY at C point we find out, so that we can mention here YC and put the value 15.75 x into x is equal to 5 cube plus our constant C1 92.35 into x is equal to 5. Second term as 0 because 5 is given, 5 minus 5 0, plus 5 by 24 5 raised to 4 minus 5 by 24 5 minus 3 raised to 4, and after simplifying EIYC is equal to, simplification of this term is equal to 260.50 divided by EI. Now 260.50 and EI is equal to 40,000, and what is the value of YC? YC is equal to 6.51 10 raised to minus 3 meter, and we can convert into mm also. In mm 6.51 mm. This value is plus, so can we write in down direction, because okay, if our deflection is positive, because deflection of this beam is like this, because of this loading beam is deflect like this way, and this deflection is downward, so that if we get a positive value we mention this is downward direction. Okay, just now we stop this example because our example is complete. In next session we solve the example of overhanging beam with Macaulay method. Okay, today's session is complete.